All right, let's get started. Sorry, I'm a bit late today. Um, so what are we going to do? Today we will do latent Dirichlet allocation. Okay. So before we start, I thought I'll show you guys. I'll show you guys what I did last night for another 5 minutes of my running project quickly. So, so this is basically the Russian troll accounts supposedly that's been publicly released to the U.S. politicians by Twitter. So we grabbed it last time, and then I just was, curious because supposedly these bots are very clever. They have profiles of each individual from their historical behavior and have some kind of information about their personalities and so on. And they're supposed to be very intelligent, and they're also trolled. That means there's human operators behind the loop, supposedly. So if this is all the case, then if we can find people who've been influenced by them, maybe there is something to get into, basically. So first of all, I just wanted to make sure that out of my sort of 13 million retweet events that I collected during the US election, if there are any of these Russian bots. And I just did a quick join some data sets, and I did find, interestingly, 12,347 of my 12.98 million retweet events during the 9-week period in the US election from last year are original tweets by these bot accounts that have been retweeted by someone. Okay, someone that's and 293 are bots retweeting others, right? Could be one of the politicians or people related to it. So anyway, this is for those who weren't here yesterday. I'm basically doing a project in my own course as an example. So you guys should have this sort of running project notebook in your own community edition of your ideas. And next week, maybe the beginning or after the FICA next Wednesday, I will sort of maybe randomly volunteer someone to give a run-in commentary of your own projects, okay? Kind of idea. All right, so today's topic is a very, very popular model called latent Dirichlet allocation. So I think what I'm going to so all of you should have this notebook now, right? If you updated the BBC archive file. Okay. So what is LDA? LDA is essentially unsupervised classification method. It's extremely customizable, very, very powerful, and it uses probabilistic modeling to discover hidden structures in your data. And originally it was developed in the context of genetics. So you must know about structure, right? Yeah. So Jonathan Pritchard and Peter Donnelly are the main authors of this paper, 2000 in Genetics. And Peter Donnelly was also my postdoctoral mentor at Oxford. So anyway, instead of me going into what this is, we're going to watch like maybe 20 minutes of a YouTube video, a very recent one from Edinburgh, by the main author of these faster scalable versions of this algorithm, David Blake. So, and you guys must have read this paper, right? So, for instance, so this, he moved to, anyway, he moved to Columbia now, right? So this is the Data Science Institute in Columbia. It has some of the most interesting people in data science and the focused there in New York City. So we looked at this briefly. Remember, you were supposed to read it, maybe. If you haven't, we'll just quickly watch this video for the 20 minutes to get it directly from the man. So let's see. I think I just posted this morning to the meetup. Let's see. So I don't know where the discussions appear. Maybe here. I have no idea. So let me see.
You should just Google it on YouTube.
Yeah, that's what I'm gonna do.
From ballistic topic models and user behavior.
Yeah, is this the one? Yeah. Let's see.
Yeah.
This is the one, I think.
Yeah.
Okay, so let me pause this. I'm gonna stop our stream.